All right, so today we're going to talk about a reflection. Okay, and a reflection is simply a flip over this thing called the line of reflection. Okay, each point in its image are the same distance from the line of reflection. Okay, a reflection, remember, is also an example of rigid motion, meaning it doesn't change its shape or size. Okay, so no rigid, it's a rigid motion. Okay, and some common lines that we reflect over, we're going to reflect over the x-axis, the y-axis. Okay, the vertical lines of x equals some number. The horizontal lines of y equals some number. And then we got y equals x and y equals negative x, which are diagonal lines, which we'll talk about. So just a quick reminder, I've said it already, but x equals some number. X equals some number are vertical. Y equals some number are horizontal lines. Okay. There are some rules to reflections. So like if I reflect across the x-axis, I change the value of my y. If I reflect across the y-axis, I change the value of my x. And then the two rules that you definitely will have to memorize for this unit are these bottom two, which are my diagonal lines. And the y equals x line, if I reflect over that, I switch my y and x. And then the y equals negative x line, I switch my y and x and also change their signs. Okay, everything else you can do with counting, so let's go ahead and approach it. So they give me a triangle ABC, which is at -4, 2. So here's my A, B is at 4, 7. And C is at 5, 1. So here's my triangle, and they want me to reflect it over the x-axis. Well, if I look at this, A is 1, 2 spaces away, which means I need to go 1, 2 spaces away. So here is A prime. So A prime is at -4, -2. Again, if you go back to your rule, it says change the value of your y. That's exactly what I did. If I look at B, B is 1, 2, 3, 4, 5, 6, 7 away. So I need to go 1, 2, 3, 4, 5, 6, 7 away. Here is my B prime. And again, if you look at it, it's going to be at the same x value, but then the sign of my y has changed to -7. And then C is only 1 away, which means I need to go 1 away on the other side to get my C prime. And same idea, x stays the same, y changes to negative. So here is my new triangle reflected over that x-axis. Okay, you can do the same thing for the y-axis. So if I have P, which is at 1, 2, Q is at 2, 5, R is at 8, 3, and S is at 7, 0. Okay, and this time they want me to reflect over the y-axis. So this time we're going to count side to side. So P is 1 unit away. So P prime will be 1 unit away. And if you look at it, this time the x now changes signs, but the y stays the same. So if I look at Q, Q is 1, 2 away from that y-axis. So Q prime is 1, 2 away. It is right here. So again, the x has changed signs. It's now at -2, 5. R is 8 away when you count all that. So if I count the other direction, I'm going to get 8 again. So R prime is over here. And again, the R changes, the X changes signs. So it's -8, 3. So that means that for S, S is 7 away. So that means to go 7 the other direction. Okay, and here you get your new shape. And S would be at, again, change the sign of the X, which is at -7, 0. And that's the idea that you have to do there. Now with the next couple lines, there is no rule, right? So j is at 1, -1. So that's j. Okay. K is at 2, +3. So here's k. And L is at 3, -2, which is right here. So here is my triangle. And the line they want me to reflect over is x equals 4. Now x equals, remember, is a vertical line. So I go to 4 and draw a vertical line. So now we need to count from that line. So L is 1 unit away. So that means L prime would be 1 unit away right here. So my new ordered pair, now there is no rule to this. So if L was at 3, add 1, 2 to it. So it's going to be at 5, -2. If you look at J, J is 1, 2, 3 away. So you need to go 1, 2, 3 away to get J prime, which is right there. And J prime looks like it is at 7, -1. And K is 1, 2 away. So you need to go 1, 2 in the other direction to get K prime. So here's my new triangle. You can see it clearly reflects it. K prime looks like it is at 6, +3. Okay. Same thing if you're going the other direction. So if I got my parallelogram here, -4, -4. Right here. So here's my C. D is at -2, 0. 6, 1 is my E. And F is at 4, -3. So here is my parallelogram. And this time they want me to reflect it over the line y equals 2. So again, y equals, that is a horizontal line. There it is. So this time we're going to count up and down. So if you look at E, E is only 1 away. So that means E prime is going to be 1 away on the other side of that line, which is at +6, 3. F is 1, 2, 3, 4, 5 away, so I need to go 1, 2, 3, 4, 5 in the other direction, which would be at 4, +7. D is only 1, 2 away, so I need to go 1, 2 up. So D prime is here, which is at -2, 4. And C is 1, 2, 3, 4, 5, 6. So I need to go 1, 2, 3, 4, 5, 6. C prime is way up here. So when I map this, you can see it clearly reflects, and C prime would be at -4, 8. Okay. The last two examples are my diagonals. So if I have x, which is at -5, -2, and y is at -3, 4, and z is at -1, 1. And they want me to reflect it over the line y equals x. Now y equals x is this line right here. Is it a diagonal line? It starts at the origin and goes up 1 over 1, up 1 over 1. And the rule to this tells me I'm going to take each ordered pair, and we are literally going to switch their x, y. So currently it's at -5, -2, which means x prime is going to be at -2, -5. I just literally switch them around. So that means if y is at -3, 4, that means y prime will be at 4, -3. Just switch them around. And z is at -1, 1, so that means that z prime will be at 1, -1. So here is my new triangle. Okay. Same thing for y equals -x. Let me draw my shape here. A is there. B is at here. C's here. D's here. Okay. Y equals -x goes like this. Okay, and this time what they want you to do is they want you to switch them around and change their signs. So that means that A prime, when I switch them, would be at 3, -1, but then switch their signs, you're at -3, +1. Right here. So that means that B prime would be at -6, 0. C prime would be at -5, -3. And D prime would be at -2, -2. And there you go.